For the guys online then, I'll just share the question for 2 seconds. For a couple of minutes. Share that. Alright, so for those online, just have a wee look at that. Okay, so this is a question we're looking at here. Okay, so what we've got, circular, and we've got the depth of water. Okay, when I'm seeing that, I'm looking at that, I'm seeing a circle question. When circles come up, we're either looking at arcs or looking at or chords. Okay, and this one's a chord. They're giving you information that will allow you to create a right angle. Okay, a right angle triangle. So we're on the lookout for that. Okay, so when we've got a straight line that cuts the circle, okay, but doesn't go through the centre, okay, we're looking at a chord question, and we're looking in our mind to find a right angle triangle there. Okay, so you will be able to get this, take a wee picture of it, or just take a wee note of it. Okay. Okay, so I'm going to stop sharing that for the guys online. Guys in the class will still be able to see it in the board behind me. Okay. Okay, so let's have a wee look at the information we've got. Typical setup for these type of questions. All right, the depth questions are a really common one. Given this, but this is quite an obscure way of asking it. Okay, so they've given us the distance or the depth, sorry, of the water or some sort of liquid going through that. And then they've given us this as being X, okay, and they've labelled that A and B. And they've given us the distance from A to B being 18, okay, and the distance or the depth being 5. Badly written, 5. Okay, now I'm looking at that, oh, they've given us X as well. Okay, my first thought is, okay, let's just draw in the right angle, just for my own sake. And remember that OB distance, and you could draw OA if you wanted, that OB distance is radius. All right, so before tackling any of the question, that's what I'm looking at there. Okay, so I'm filling in as much as I can. Part A. Part A is looking for an expression for X in regards to R. Okay. Now, as we go through more past papers, you get more and more used to building up your own expressions. We do this in quite a lot of questions. It will be a question in your exam where you'll have to do this. Okay, so you'll be given things like this. So sides of a triangle, you'll have to build up sort of expression. Okay, so what they're looking for in terms of X means what does X equal? Okay, now they're asking you to use the letter R. So R, in this case, stands for radius. Okay, so they actually tell you that in the question. So with that third line, the radius of the pipe is R centimetres. Okay, so in terms of R for radius. Okay, so put R in there and then look back at your circle. Okay, so we know that O to B is radius, but we also know that the origin to the bottom of that, okay, origin, centre of the circle, okay, to the bottom is that distance there. Okay, so that O to the bottom, we can call that another letter if we want to C. That O to C that I've drawn on there. Okay, well that's X plus this 5. Okay, or another way to look at it, if that full distance from O to C is the radius, if I take away 5 from that, then I'll be left with X. Okay, now that's sometimes a wee bit hard to see. That's why try and draw this out. Okay, try and make sense. Start scribbling on it if you wanted. Okay. So if I say r minus 5, okay, so that distance O to C is a full radius. If I take away 5, I'll be left with x. So x equals r minus 5. Okay, that's the easy bit. That was probably worth the mark. B is, yep, a wee bit more difficult. Okay, so B, what it's going to ask you for is calculate the radius of the pipe. Now, what we're going to use is a bit of Pythagoras. So let's draw out a right angle triangle. All right, let's draw out a right angle triangle and put what we now know on it. Now flip that round. Let's make it a wee bit smaller. Okay. I've lifted my right angle triangle. Now it's facing a different way, so I'll just draw that on. Okay, so if you imagine I've lifted that triangle out, that's O to A. Okay, so that's the radius. That's the centre of the circle to cut my chord in half. Okay, so if I was to carry on that line, I would get to B. So A is half my chord length. Okay, now given the chord length over here is 18. So remember, if I bring a straight line down from the centre of the circle to touch the edge, and it cuts my chord in half, that leaves me with a right angle triangle, but it also leaves me with a distance here of 9. Okay, and then got this letter X. Okay, right, so we've got something we can do Pythagoras with, but I want the letters to be the same. Now, they've given us this information up here. They've made us do this for a reason, so we're going to have to use this. Okay, so instead of R in there, if I rearranged that, okay, I could rearrange that and write that as R equals X plus 5. So I could have this as X plus 5. So the distance OA is X plus 5. Distance O, the bottom of this corner, is X, and the distance A to that corner, for that D sake, is 9. Okay, so we're building up a wee picture here. Now we go back to Pythagoras. What is Pythagoras? Long square equals short square plus short square. However you want to write that, it's absolutely fine. Okay, long squared is X plus 5. Short squared is our X plus, right? Still screwing with us. Okay, I'm like, still not seeing it. But let's split that bracket up. Okay, so you should be comfortable with splitting brackets up. X squared plus 10x plus 25 equals x squared plus 81. Okay, I'll just write that number out. Okay. If I bring over this x squared term from the right hand side to the left hand side, it becomes a negative, and it then rules out that other x squared. Okay, so I can now x squared minus x squared takes them away, leaving myself 10x plus 25 equals 81. Okay, I can then rearrange that to 81 minus 25. (56/10). Okay, just moving the decimal place once. Sorry, run out of space. 56 over 10. 56 over 10 is going to give us 5.6. So X we've now got a number for. All right. So we've got that position where we've got a number for this letter here in our original diagram. Okay, we're trying to find radius. So we're trying to find that full distance from O all the way to the outside edge. So we've got a number for X now. We've got X is equal to 5.6. And we know that the radius is that X plus another 5, which is the depth we were given at the start. All right, so our radius is equal to X plus 5. Okay, we're given, or we worked that one out. 5.6 plus 5, 10.6 centimeters. All right, and the answers are down the bottom. Okay, so that's just a recheck.
See, I got that answer, but my tutor's done it like a totally different way to that.
Uh-oh. Right, go for it.
So the way that she got it is she got me to like obviously draw out the right angle triangle.
Yeah.
But we done it sort of like we done this sort of long squared equals short squared plus short squared. But she then just carried down, rather than doing the x plus 5 in the bracket squared on the left hand side, we broke the brackets on the right hand side and made it plus 81.
The bracket.
So I would have like r minus 5 in a bracket, r minus 5 in a bracket plus 81.
Oh, so you did it in terms of R.
Yeah.
Yeah, that's okay. So okay, that still works. So R. Everyone copied that? Comfortable? All right. Let's fight the chill. I'm joking. It still work. Okay, it's just so instead of that X plus 5, you kept R there.
Yeah.
X and 9.
But then see how where your x is? She
Yep.
got me to write the r minus 5.
Okay, yeah, that makes sense.
And then in the brackets I had r minus 5 squared plus 9 squared.
Yeah, okay, that's
And then we just worked it out that way, like breaking up the brackets, adding like all the same thingies together and then dividing it all.
okay, perfect. So yeah, that works. So instead of that, I changed it all to suit that variable, whereas
Right.
she's changed it, or they've changed it to suit that variable. It's the exact same, just essentially. So for everyone else's sake, I'll just write that one out. Okay,
Yeah.
so long side squared is r squared equals short side squared, which is your r minus 5 squared plus 9 squared.
Yep.
R squared, what do you have? Minus 10x, yeah, r, sorry, and then plus 25.
Yep.
Plus
81. Yeah.
Yeah, perfect. Okay, and then r squared, let's tidy that up a wee bit. Squared minus 10r plus 106.
And then she moved the r squared over to the left hand side and made it r squared minus the r squared, which cancelled that out.
Yep. So you can move either one to either side. It's just about cancelling that out. And then you can move that 10r as well over to the left hand side. So that's cool.
Yep.
R squared minus r squared. But no, I'm going to bring this 10r over first.
Yeah.
I've left myself something on that side, and then I'm going to bring the r squared over and take it away. Okay, they cancel out.
Mm-hmm.
Yeah, that's.
Yeah.
Exactly, this, yeah.
Yeah.
Perfect.
Okay, that's fine. I just wasn't sure, like when I seen it, you do it, you're like the way that you do it. I thought, oh, if she maybe like missed out steps or something like that.
No, it's exactly the same. That's actually a wee bit easier because it goes straight to R, whereas I got X and I had to then add that 5
Yeah.
back. So that's actually a wee bit easier. So
Okay.
works out. I want to. All right.
Okay.
Nice one. Super.
Thanks.
Nice one. Okay, so 2017 paper 1, question 6. So I think that's one of the first straight line worksheets. Okay, it comes up on. You're given 2 coordinates. All right, so you're given -1, 6. You're given 3 to -2. So remember what we're looking at is for x1, y1 when we're numbering them, x2, y2. Now, don't worry too much about which way round you do that. Okay, I usually go from left to right. Some people go from bottom to top. Okay, don't worry. As long as you're consistent with our x1, y1, and x2, y2, as long as they're the same coordinate, it will still work out. Okay, so first thing we're looking to do, work out the gradient. Remember, the gradient is given by the letter m. And we find it by y2 minus y1 over x2 minus x1. And we're just substituting in the numbers. So y2 is -2, y1 is 6. Okay, x2 is 3. And our x1, and be very careful here, is -1. So taking away a negative, you're then going to create an add. So be -8 and was it 4 down there? Leave yourself in -2. This line there, that denominator part where you're taking away a negative, a lot of mistakes come from there. Just be very careful with that. So essentially that turns into 3 plus 1. Okay, and you're left with a -8 at the top divided by 4, and you're leaving with -2. Okay, just be careful with that. That gives you the m that goes in your y equals mx plus c. Okay, so you've got the m that you can substitute in there, and then you've got that. Now at this stage, all we're doing is substituting in one of your coordinates, either one, it doesn't matter. Okay, so it's coordinate number 1. Okay, so if I substitute coordinate number 1 in, the y value is 6. So where the y is, I'm going to put the y coordinate. That -2 is there, and it's multiplied by my x coordinate, which is -1, and plus c. I'm going to rearrange this to find c. Just rewrite it, just break that bracket. That will just become the number 2 because it's -2 times -1. When we multiply negatives, we're getting a positive plus c. Now remember when we were rearranging equations last week? What we can do with that, because it's an equal sign, we can just flip that round and it gives us the subject that we want on the left-hand side. So we're getting 2 plus c equals 6. I've not changed anything there, I've just turned it around. And that just puts the subject that I'm looking for, in this case c, on the left-hand side. It makes it a wee bit easier when it comes to moving things about. In this case, the 2, to isolate the c. I'm left with c equals 4. I can then substitute that into my y equals mx plus c. My final outcome is 2x plus 4. All right, so remember that m is gradient, that stays consistent. That is the y coordinate. Okay, and the y and x there is how you can find any coordinate on that line. Okay, so any coordinate on that line, if I knew one of the numbers, the x or the y, I could find the other one. Okay. There might be an additional part to that, so they could ask you an additional part. What is y when x equals 1? All right, they don't ask us in this past paper question, but they could ask that. What is y when x equals 1? And all we do is just substitute that in. So y equals -2, 1 plus 4. Y equals -2 plus 4. Y equals 2. So our coordinate would be x equals 1, y equals 2. Now, does that make sense in that line? Yeah. All right.
Would it be like 0, 2 or 1, 2?
1, 2. Because when
1,
x
2.
is equal to 1.
Oh, yeah. Sorry.
When x is equal to 0, your y coordinate, your y intercept, so it'd be 0, 4. Sorry, no, it's not. Okay, so that's the easiest way they can ask that. Okay, so if we go back to that screen, all right. I've done our sharing. Right. We go back to this. Open that, right? And they can give it in the terms of a nice wee story question. Now, there's nothing different happening here. Okay, we're looking, in this case, we have to create our own coordinates. Okay, so this is being able to read the graph. Okay, but nothing is different here on what it's expecting from us. You're looking for two coordinates, which allows you to find the gradient. And then they're asking you to substitute something in. Okay, so that's the last part I did there. Okay, so let's try this one, looks a wee bit easier. Let's have a wee look at this one. Okay, you've got the P up the y, what we call the y-axis. Okay, so the P is our vertical axis there. P in this story means pounds. Okay, so that's the cost up the y-axis there. So instead of a y coordinate, we're going to have a p coordinate. Okay. The x for us in this one is that we value d. Okay, so the d in this question is the distance. So we've got a graph showing the distance and then the cost. All right, so something we're mostly familiar with. All right, anyone's got a taxi before, the more you go, the further you go, the more you pay. Okay, point A represents a journey of 8 miles. Okay, so the x value there, the distance is 8. The cost is 14, so the p value in pounds is 14. So your coordinate on that straight line is 8, 14. The second coordinate is 12 miles, so 12, okay, for our position x, and our y value would be the 20. Okay, so it'd be 12 and 20. Okay, so we've got two coordinates there. With that information, try that question. I'll give you until 10 past. All right, if you can get it, if you're comfortable with it, then move on. Work through that worksheet. Okay. I'll go through this one at 10 past.
Is this checklist for everything we need to know over
Yeah.
the whole of that value? I just can't see standard deviation.
Oh, it's there. It's the last one. All right, guys. So what were we? 2018 paper 1. 2018 paper 1, and it's question 7. Okay, first part of it, we're getting our coordinates. Oh, no, sorry, we're doing an equation in terms of P and D. Okay, so y equals mx plus c is what we normally know as. The y is always the vertical axis. X is the horizontal axis. Okay, so in this question, when we're looking at that, P is our vertical and D is our horizontal. Okay, so we're going to rewrite that in regards to y, which is P equals md plus c. So our coordinates format, instead of being x, y, will be p, or 1, will be d, p. Okay. So m, y2 minus y1, okay, which is just our vertical, change in vertical. X2 minus x1, change in horizontal. Okay, no matter the letter, it's always vertical over horizontal. Okay, so for our coordinates, A was 8 and 14, and B was 12 and 20. Okay, so x1, y1, to y2. Okay, we want to do E1, E1. You don't have to do this like the D and the P's all the way through. Just keep it in X's and Y's. Makes more sense. All right, so substituting that in, our Y2, our vertical, or second point in our vertical is 20, minus first point is 14, second point is 12, minus our 8. So that's 6 over 4. And simplifying that as far as possible, with the number 2 goes into 6 3 times, and it goes into 4 twice. Okay, so our m value is 3 over 2. And that's perfectly reasonable, even in a non-calculator. So remember, P1, paper 1 is non-calculator. A fraction like this is perfectly reasonable. Okay, so taking that m value into our y equals mx plus c, or our p equals e c. Remember, c is just y-intercept, just the letter we use. It's where it cuts the vertical axis. Okay. Substituting in a coordinate, any coordinate. So our coordinate 8 and 14 can be substituted in. Okay, so 8 is a D, 14 is a P. 14 is equal to 3 over 2, 8 plus C. Remember, when we've got a fraction multiplied by a number, okay, which is essentially what that is, okay, you multiply that top line first, and then divide by the bottom line. Okay, so 24 divided by 2, which is 12. Okay. You could also, if it's easier to do, you could do the 8 divided by the 2 first, multiplied by the 3. Remember, you can do divide and multiply in any order. Okay, whatever the simplest way to do. So 4 times 3 will also give you the value of 12. Okay, so when you've got a fraction like that, do it in the simplest way. Okay, so get that to 12 plus c. Okay, I want the subject that I'm interested in on the left-hand side, so just we'll switch it out and solve that. And then that will leave you y equals mx plus c, or in this case, p equals md plus 2. Okay, this is the bit that I tried to get on that last example, okay, where you might be asked to substitute something in, okay, something different. So calculate the cost of a journey of 5 miles. Okay, so let's look at what P equals 3 over 2 P plus 2. P is the cost, P is the distance. Okay, so we're getting asked for the cost when we're going 5 miles. So we're taking that 5 miles and we're substituting in to where the D sits. So the P is equal to 3 over 2 D, which is 5 plus 2. D equals 3 times 5 is 15, divided by 2 is 7.5, plus 2, P is equal to 9.5. Now remember, it's a cost in pounds. The cost, 9.5 pounds, or £9.50. Write it out with a nice pound sign. Okay, so that's what I mean by the substituting in another variable to find out an unknown. Yeah. Next question. Okay, let's have a wee look together then at question 1 in that paper, and that all right, so this is slightly harder for the simple fact it's going to be a negative gradient. Okay, I know it's a negative gradient because that slopes downwards. All right. Y in this case is fuel consumption. Okay, the X value is going to be this engine size. Bigger the engine, the more fuel. Oh, sorry, fuel consumption, kilometers per litre. All right. So the bigger the engine, the less kilometers per litre I'm going to get. Which makes sense. All right. So, in essence, the story behind it doesn't really matter. Okay. So you don't need to know about cars or anything. You just need to know that the y-axis is F and the x-axis is going to be E. Okay. Find the equation of the line of best fit in terms of F and E, given the equation in its simplest form. Okay, so you're going to start with y equals mx plus c, and you're going to be trying to find the gradient. Now, to find the gradient, we need 2 points. Okay, the points which you're looking to pick off. Now, there's lots of wee dots there, but you're looking for points on that line. Okay, you're looking for points on that line, so there's 2 points exactly on that line. Okay, so I'm just trying to annotate this. I'm trying to find the wee.
See, if I'm looking at this right, is that going to be like halfway between like 3.5 and like 1.5? Because that's where the dots are.
Absolutely, yep. So you've got a dot. Oh, sorry, that's terrible. You've got a dot at 1.5, you've got a dot at 3.5 on the x-axis.
So, what are the ones that are right on it?
Yeah. There's a wee spotlight. There's a wee spotlight. Okay, so that point and that point are right on the line. So these are the 2 points of interest. Okay, now the coordinate of this, reading off the graph, will be 1.5, where my x coordinate, my y coordinate for that is 14. So it'll be 1.5, 14. That's my first point. That's my x1, y1. 1.5 and 14. For my second point, it's 3.5 for my x2 value. My y2 value is 8. Yeah, so those 2 points will allow me to find the gradient. My gradient is going to be y2 minus y1, which is going to be 8 minus 14. And that's going to be over 3.5 minus 1.5. I'm going to get negative 6 over 2. I'm going to get negative 3. Okay, so I'm going to get a gradient of negative 3. Lost anyone? Okay. So we've got y equals negative 3 x plus c, or if you're using the letters, okay, my y-axis is f, negative 3, my x-axis is e plus c, okay? So at this stage, I've got f equals negative 3 e plus c. Sub in our coordinate. Okay, so I'll have the 14 equals negative 3 times 1.5. I'll write this up. Plus c, and then rearrange for c. Again, c is 18.5. All right, now I'm gonna stop sharing that, okay, and I'm gonna go to the board now and just complete this. Okay, so just if you want to copy it, or if you want to copy down where it's coming from, copy down where it's coming from, and I'll do it in the board. Just that last wee bit. All right.
Yeah, that's stapler.
Not to staple 130 pages.
No, it's just for the.
Right, very quickly then, coordinates. 1.5, 14. Coordinate 2 is 3.5 and 8.
Always need to find it on that, on the graph.
not always, but sometimes. So the story ones, they like you to find two coordinates. Which is that? 2, 5, goes there. C, or if we're using the letters at this point, F goes down to T. C. Sub in a coordinate. Okay, so our F coordinate is a Y value. That's how fast you should do it in the exam, okay? Okay, so that's what I sort of talked through, so that's me just writing that out. Okay, so we've got fuel consumption is the F and the E is the engine size. Okay, now what it wants you to do in part B is determine or what is it? Estimate. Determine fuel consumption for engine size 1.1 litre. All right, for engine size 1.1 litre, determine fuel consumption. So fuel consumption is -3 times engine size plus 18.5. So fuel consumption, if we substitute it in our 1.1, will be F equals -3.3, okay, plus 18.5. F is equal to 15.2. That is okay. So a lot going on there. They try and throw you off by putting lots of dots, but there will be 2 dots right on that line. All right, so they'll have to, if you see a straight line question, you have to see 2 positions on that. Okay, 2 coordinates on that line.
I get the fuel bit.
The last wee bit.
Yeah.
All right. So it's that engine size of 1.1. So the engine size is the X value. So you don't need to care the guy's called an R, all right? But the X value that you're going to substitute in is just 1.1. All right, so -3 times the horizontal value or the X value is 1.1. And that will give us a fuel consumption.
I get the basic significant and it goes up at this. I understand, like, I think it's easy enough and it's like, the actual formula and all that, but it's fine, but when it gets to the, I've got it.
They'll just make you substitute a number into one of the positions. All right, for straight line, it will usually be in the horizontal axis position. There's no reason why they couldn't give it a Y value. It's a lot harder to rearrange, but there's no reason they couldn't. All right. Any questions online?
No, that makes sense. I'm glad now I can figure out where the points are and all that by looking at the graph.
A lot of huffs. Alright, so we're given 2 points. Okay, so we pull that off the graph. We're given point D being the coordinate of 3 and don't know why I'm trying to read that. Put it right in front of me. 100 and second point's been 15 and 340. Okay, so when we're finding out the gradient, that's a horizontal, vertical, horizontal, vertical.
That's exactly where I went wrong. I've done it the opposite way round.
So as in this being the first coordinate,
Yeah.
so that should still work. All right, you should still get the same gradient. It's
Mm.
just makes it a wee bit messier. All right.
Yeah.
So y2 will be 340 minus 100. Sorry. Okay. Now, some of you might have seen straight away that 24/12 is quite an easy one, just because there's a sort of zero attached there. Doesn't harm that calculation too much, so you could do 240/12 and it works out as 20. Okay, or another way, we can simplify that down as far as possible and make the numbers a wee bit more digestible. So if you have those numbers every time, okay, so remember, if it's got a 5 in the end, look for dividing it by 5, or if it's a big number like that and it's even, half it and half the number underneath as well. So you can do 120/6. You can make that simpler again by doing 60/3, and now it's a much easier fraction to sort of look at and you can get the number 20 out. Okay, so gradient is 20. It's a positive number. Look back at your graph. Does that make sense? Yes, it's sloping upwards. Okay, so that's a good sign. So we've got y equals mx plus c. Y equals 20x plus c. Okay, so we're not using our new letters yet. You don't have to. Y is our vertical, x is our horizontal. Okay, so we can substitute in a coordinate. Okay, 1 or 2 into that to then find our missing letter or c. Okay, so 100 equals 20 times 3 plus c. Okay, so 60 plus c, if we turn that round, c equals 100 minus 60, c is equal to 40, and then we're getting y equals 20x plus 40. Okay, now it asks you in terms of a and y. Your y's are vertical, so instead of y, we're going to have the letter w. And instead of the letter x, which is a horizontal, we're going to have the letter a. And that's our sort of final answer.
I was close until I had got to like the 60 plus C. I kind of flipped it before that. And
Okay.
then I had made it, I had, when I had switched it over, I did a plus instead of the minus. So I kind of messed it up there, but I got the gist of it.
So we have 160.
Better than where I started. Yeah, I got 160.
All right. Don't let this bit confuse you. All right. Literally just turn it around. We're not doing anything to any of the signs. Just keeping it the same, but just puts the subject of it over on the left hand side. All right. So part of that process of when we're flipping equations. Okay. So it's then asking you wait for half of 1 year. Now, quite unusually in this, it's not actually giving you in what you're substituting in. You need to then work out that that's 12 months. People should know that, all right? So, not great, but you should know that. All right, so weight equals 20 times 12 plus 40. All right, now 20 times 12 is a wee bit difficult, okay? Bizarrely, it's the opposite of when we did this fraction. All right. So you've already worked it out in reverse. Okay, but remember, when you've got things that are multiplied like that, you can break that multiple down and do it in a different way. So you could do 2 times 10 times 12. And it's a slightly easier to do, all right? Because then you could do the 10 times 12 and it'll be 2 times 120, which would give you 240. All right, so remember you can break multiples down if you wanted. So you can break that down, that 20 down, into 2 times 10, and then rearrange it a wee bit. Okay, so that's a good thing to be aware of and sort of be comfortable doing. Okay, so W equals 240 plus a 40, 280, and our weight is in kilograms. Okay, again, a wee way to sense check that is, well, they're asking you for 12 months and we're getting 280 kilograms. They've given us already the weight in the question of a calf that's 15 months old, so a calf that's older than the one they've looked for, all right, and it's 340 kilograms. So you'd expect one younger to be less. So again, that's a good sign, all right? So if you'd done that and instead of the 40, you'd got the 160, and you were getting an answer of 400. A wee sense check would be, that doesn't make sense, because if it got older, it's not going to get lighter, unless something's going wrong, okay? And then that would allow you, that would then show you, all right, maybe I'll double check something back here. All right, so there's wee sense checks, wee bits that you can go to. We good online?
Yeah, that makes a lot more sense. I had just put my, like I said, my coordinates into like the different